right, so exam 2 review. Yee-hoo. All right. So exam 2 is going to cover 9.3 to 10.1. We started off our work for this exam with problems with radicals. And the thing to do with the radicals for some of these early problems is to split it up into 2 parts. Part of it is a perfect square, part of it's, whatever's left over. Now, it's helpful to have your perfect squares memorized, like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc. Let me go a little further. 144, 169, 196. Woohoo! Yeah, rocking. All right. I have to tell you about Gauss sometime. Gauss is one of the premier mathematicians of all time, and he was really prodigious with mental calculations. Anyways, so of the perfect squares, you work your way up the list, and the largest one that goes into here evenly is 25. And it goes in there 6 times. But then you have to deal with the x. And x squared is a perfect square, so I'll put that in the first radical. Now, if they tell you that you can assume that the variables are positive, then you wouldn't need the absolute value here. If that assumption can't be made, then you would need the absolute value. We're going to assume that they can be made in this one, so that would be 5x times the square root of 6. Yay! And that's it. Now, I chose this one because the exponent here was odd. And I want to remind you what to do with something like that. So, kind of like the last one, I'm going to break this up into a couple parts. And the first part is going to be our perfect square. The second part is going to be whatever is left over. Now, as far as numbers that go into 343 evenly, I'm thinking 7 goes in there 7 times, or 49 times, right?
49 times.
Yeah, so 49 times 7 gives me 343. So here's your perfect square part, here's the other part. Now, perfect square parts for a variable, that's going to be when the variable is evenly divisible by the power of the radical. So when it's evenly divisible by 2, then we're in good shape. But 5 doesn't go into 2 evenly. So here's how we're going to do it. We're going to split that up into 4 of them here, and then the extra one here. So now we're in good shape. Now we take the square root of 49, you get 7. Square root of this, keep in mind, our work from rational fractions, that's really 4 divided by 2. The 4 over 2 power can be simplified to 7a squared times the square root of 7a. And that's it. Done. Okay. So the next one is really nice. You should be lucky if I give you one like this on the exam. 20 times the cube root of 6 minus 15 times the cube root of 6. Notice that you've got the same term both times. It's cube root of 6 and cube root of 6. And if that's the case, then really all you have to do is subtract the coefficients. So what you get is 20 minus 15, which is 5 times the cube root of 6. And you're done. Whoa!
That was easy.
Yes. Sweet. So, nice one. Now, you might look at this one and go, oh, hey, there's nothing we can do. These aren't like terms. Not so fast. We can make them like terms. And let's see if we can't figure out how. Now, I'm going to go a lot faster than you will on a test, but that's okay. You're going to have plenty of time to work on these. So, square root of 147, that's going to be square root of 49 times the square root of 3. 192, again, you're looking for perfect squares. That's going to be 64 times the square root of 3. And if you start seeing a little pattern like, gee, everything's multiplied by the square root of 3, then you might say, oh, well, let's see. Let's take 108 and divide it by 3. Oh, yeah, we get 36. Cool. So, all right. That's going to simplify to 7 square roots of 3 minus 8 square roots of 3 plus 6. This should be a minus. 6 square roots of 3. Pardon me, that last one's a minus. So here we go. Never happened. Beautiful. All these are like terms now. Combined coefficients. 7 minus 8 is negative 1. Negative 1 minus 6 is negative 7. So we should end with negative 7 square roots of 3. You can check on your calculator that you get the same value here that you do with the original problem. And that's pretty good evidence that you did this right. I don't want to say conclusive, but because I'm sure that there's going to be some way that might not work, but it's overall it's in good shape. I used to put test problems like this on there thinking, oh, hey, I'll give them an easy one. But it became a lot more confusing for people than I really intended to. By the way, let me make sure that that square root goes all the way down to the bottom. So what I do here, I put everything underneath one radical. And the reason I did that is because I saw something that looked pretty promising. 2 goes into 128 how many times?
64.
64. Square root of 64, and then x cubed divided by x is x squared. Now, this one, we have to assume that the variables are positive, because otherwise the denominator would be undefined. It would be the square root of a negative number. So I don't need the absolute value here. It's just 8x. And we're done. Yay. Woohoo! Onward. Let's take a look at this next one. Square root of 7 times 2 square roots of 21. That's going to be 2 square roots of, well, 7 times 21 gives me 147. And if you're curious, what I'm doing, even though it's not written, it's understood that there's a 1 in front of this radical. Let me write it in green here. It's a little bit easier. 1. So the things outside are going to multiply. 1 times 2 is 2. Things underneath are going to multiply. 7 times 21 is 147. Same thing applies here. 1 times 8 is 8 square roots of 35. Now that's not bad. That's a good start. That's 2 points out of 3, or maybe 2 points out of 4. Depends on how I grade it. But there's a little bit more you can do with the square root of 147. And I'm looking back. I don't think we've dealt with square root of 147 yet. Oh, yeah, we have. That was square root of 49 times the square root of 3 plus 8 square roots of 35. Square root of 49 is 7. Make sure you get rid of the square root when you take the square root of 49. Some people leave the square root around the 7, and that's a mistake. And then finally, 2 times 7 is 14. So 14 square roots of 3 plus 8 square roots of 35. And went off to the edge of the page there. Yay, done. I'll be honest with you, this work with radicals is not my favorite part to teach. It's just not. I know it might be kind of a drag for you too, but you know what? It's just a little bit of stuff, a little bit of pain. Get through it, get a good education, get a good degree, and you'll be happy that you did.
Is there a quick trick that you have to easily identify a number that can't be broken down anymore, like how 35 is? Like, or do you just know just from experience?
What I have to do, even in my fastest mode, I have to kind of mentally think through dividing by all these. Yeah. Now, the trick is to work your way up this list. And my favorite example to give as to why you want to work your way up that list is with 72. because if you work your way from top down, you say, oh, square root of 72, that's square root of 4 times square root of 18. And you're like, oh, okay, well, then that's 2 square roots of 18. But then you're like, oh, well, wait a minute, 18 is square root of 9 times square root of 2. So it's 2 times the square root of 3 times 2, or 6 square roots of 2. And that's fine, that's the right answer. But take a look at it if you do it the other way, if you do it my way. 72 starts right here, and work your way up. Does 64 go into 72 evenly? No. Does 49 go in there evenly? No. Does 36 go in there evenly? Twice. And watch this. Square root of 36 times square root of 2. Oh, that's 6 square roots of 2. You tell me which one you want to do. I kind of think I know. So, yeah, it's just getting comfortable with these things. There's nothing wrong with writing this list on your test. There's nothing wrong with that. If you wanted to just write it out, have it memorized, or sit there and hit the squared key, you know, as much as you like, you know, oh, what was 8 squared again? And look, there's no shame in that. You know, I'd rather you get it right than not. So do take some time to help yourself out. This one I include on exams because I want to make sure that people are squaring out the binomial like they're supposed to. And you asked about a shortcut. There is a shortcut, but and I'm hesitant to really do it on a problem like this. So the best thing to do is to multiply this by itself. So that's square root of 7x times square root of 7x, or square root of 7x minus square root of 6 times itself. Now all the stuff, all the action is going to happen underneath the radical. So it's going to be square root of 49x squared minus square root of 42x minus square root of 42x again. And if you're really careful, you'll notice the last one is a plus, because you have a minus times a minus, a plus square root of 36. Now a little bit of experience on my part here. You might notice that I left quite a gap between these two here. And that's because I want to put something here that's kind of understood but not really written. What's understood to be here?
1 is a coefficient.
Yeah, a 1 is a coefficient. And the reason I'm pointing that out is because in the next step, we're going to get a lot of simplification with this. Because these are like terms. Here and here, I have the square root of 42x. How many of them do I have? I have negative 1 plus another negative 1. I end up with negative 2 square root of 42x. And then how about this one? Square root of 49x squared, that's 7x. Square root of 36 is plus 6. Done. So the reason I give this is because a lot of times people just want to say, oh, square this term and square this term. They want to give me this. They have no clue about this middle term here that you're going to get. So there you go. All right. Looking good on those. Any questions from my homers? No? Okay. Got this? Last glance? Yeah, go ahead. Yeah. But, I mean, count on something like this. I mean, every chance I get, I give you problems that involve squaring out a binomial in one form or another. Complex numbers, we'll see it again. All right? You have to do a square of a binomial. So, rationalize the denominator. I guess I would start this one by realizing that 45 has a perfect square that goes into it. Square root of 7 over square root of 9 times square root of 5. So this really becomes square root of 7 over 3 square roots of 5, you're still stuck with a irrational term in the denominator, which we don't like.
So you
Multiply by square root of 5 over square root of 5. It's so much nicer to do it this way than to multiply both the numerator and denominator by the square root of 45 over the square root of 45. You could do it that way, but you'd be unhappy. All right? So we'll end up with the square root of 35 over 3 times the square root of 25. That's 3 times 5. That'll be 15. Square root of 35 over 15. Well, let's just check that real quick here. We can check that on our calculator. See, are we getting the same thing? So here goes. Let me clear out this stuff and then this stuff. So on the one hand, I'm going to do a big square root of 7 divided by 45. That's all underneath the radical. On the other hand, I'll do square root of 35. And then the way my calculator works is I got to exit the radical and then divide by 15. And I'm hoping I get the same numerical value exactly. And I do. So at that point, you can at least feel that you did something correctly. Hopefully it's the right thing all the way. All right. Rationalize the denominator. This is another one like the one we just did, except a little bit messier. This time, you got to multiply by something called the conjugate of the denominator. Now, the conjugate of a binomial is when you just change the sign. So instead of square root of x minus y, square root of y is square root of x plus y. But it's always based off the denominator. In the numerator, you're going to get the same thing. Square root of x plus square root of y. And the reason for that is that when you multiply by something like this, you're really multiplying by what number?
1.
Yeah, perfect. Thank you, Summer. Something divided by itself is 1. So you're not going to change the value of it by multiplying by 1. If your boss multiplied your paycheck by 1, you're not going to suddenly shower him with gratitude. All right, it's still the same thing. But in this case, as long as we don't cancel, we are going to get something nice. Square root of x squared plus the square root of xy minus the square root of xy minus the square root of y squared. Same thing's going to happen in the numerator. It's just that in the numerator, the signs are going to be a little bit different. They're all positive in their numerator. And that makes a big difference. Because in the denominator, those two terms cancel each other out. And so what you're left with is square root of x squared is x minus square root of y squared is y. And that's it for the denominator. In the numerator, let me remind you that that's a 1 here, that's a 1 here. So in the numerator, I get x plus 2 square roots of xy plus y. And that's it. And I don't think I'll be hitting this button on that problem. It wasn't too bad. It wasn't too bad. You might also get one with numbers from me like that. Okay, so section 9.5. A little bit more fun problems, at least for me. When you're solving these kinds of things, you want to start by getting the squared term on one side. So I'll subtract 2 from both sides. I want to get that square root term. I said squared term. I want to get the square root term by itself. So that gives me negative 1 equals the square root of 4x plus 50. To get rid of the square root term, I can square both sides. And that'll give me positive 1 equals 4x plus 50. And I forget who it was. Somebody ran into a problem just like this in the homework and was a little distressed about it because they figured that, oh, I got this thing right. I had no idea. Let's take a look here. If I subtract 1 from both sides, I get negative 49 equals 4x, or negative 49 divided by 4x equals, or excuse me, divided by 4 equals x. So great, all done, right? No. There's 2 more points you could and should get. And I think you want those 2 points. So what are you going to do to get those 2 points? No, you got to check it back in the original equation. Oh, yeah. Hate when that happens. So, don't exactly have room next to the problem here, so let me just kind of squeeze that on another sheet. That's going to be, does 1 equal 2 plus the square root of 4 times x plus 50? And I always like to put a question mark there, because what we're doing is we're trying to figure out, is that really true? So negative 49 over 4. Well, the 4 and the 4 here cancel each other out. And so what I'm left with is, does 1 equal 2 plus the square root of negative 49 plus 50? Or does 1 equal 2 plus the square root of 1? And maybe you can answer the question at this point. Does 1 equal 2 plus square root of 1? Is that true? No. Does 1 equal 3? No. And what that's telling you, and what you need to know and do, and boy, if you don't see one like this on the test, then go back and check. This is an extraneous solution. It just doesn't work. You did all your work correctly, extraneous. But there's no place that this actually holds true.
And this problem only has one answer?
This problem has no answers. Well, it has an extraneous solution. Yeah, when you get down to here, it has an extraneous solution. Now, this one I'm not going to do all the way, but you would get, if you square both sides carefully, this side and this side, you get 18 minus 2x. And on the right-hand side, when you square the square root of x minus 9, you get an x minus 9. But here's the part that's going to trip up a lot of people. That 2 is outside the radical. And when you square it, you get a 4. And if you go through and solve it, I do believe that x equal 9 is the solution. And it does check if you actually go through and check it. So, let's see. This one, you know what? Let's see. Let's do this one. Kind of like the very first problem that I solved in this, you want to get the squared term, the square root term by itself. So that for me would mean moving that y to the other side. Now when I move that y to the other side, 12y plus 37, if it changes sides, what else changes in it? Signs. So y plus 6. And so once again, kind of one of the things I was telling you just a little bit ago, here's what I test quite often. You have to square both sides. And what that's going to mean for us, square root of 12y plus 37 equals y plus 6 squared. It's going to mean squaring a binomial, just like we did with the radicals. This stuff happens all the time. Now on the left-hand side, when I square that, that's easy. I get 12y plus 37. On the right-hand side, yeah, y plus 6 times y plus 6. I'm going to hustle that up. That's going to be y squared plus 12y plus 36. Now, this is a quadratic equation. After we covered section 10.1, you've now got a couple ways to solve quadratic equations, but the easiest way is generally factoring. So that's going to mean getting 0 on one side. So I'm going to subtract 12y and 37 from both sides. And let's see what that gives me. Well, on the left-hand side, I get what I wanted, which is a 0. On the right-hand side, I get y squared. Those cancel. Y squared and then what? Minus 1.
Minus 1.
Yes, thank you. Beautiful. And it's up to you how you solve this one. You could factor it and solve it pretty easily. Y minus 1 times y plus 1. Or you can move the 1 to the other side and say, oh, I'm going to use the square root property. Take the square root and get same thing. Now, that same thing is y equals 1 and y equals negative 1.
Can we do it as y equals plus or minus 1? Like
Yeah.
shorthand?
Well, you know, I don't mind having it written out like this because there's one more thing you got to do. Not as if this problem isn't long enough already, right? It feels like kicking a guy when you're down, but I'm sorry, but there's one more thing we got to do. What is it?
Check our work.
Got to check the answers, yeah. Because if you put in a positive 1, let's see, I'll end up with square root of 49 minus 1 is 6. All right, so yeah, square root of 49 is 7. 7 minus 1 would be 6. That one checks. But negative 1, I'm afraid, well, let's see here. If I put in a negative 1 here, that's 12 times negative 1 is negative 12, plus 37 is square root of 25. What's the square root of 25? 5. 5 minus negative 1 is 6. So they actually both work, which, you know, there's three possibilities. You could have both solutions work, one solution work, or none work. All right. So it just kind of depends on what I write. I'll be very candid with you. Generally, I write this so that at least one of them doesn't check. That way, I make sure that you're checking these things. All right. Let's move on to this one. You should be able to write out, this is something I do every now and then, I just ask you, you know, to write out, well, what's the distance formula? You should be able to write that out. What's the midpoint formula? Again, write that out. And of course, last but not least, write out the Pythagorean theorem. I don't know if I'll ask you to write out the Pythagorean theorem, but you certainly should expect to use it. And I'm hoping that's going to be an easy problem for us. So let's take a look at it. So let's see here. You don't have to draw your right triangle, although I will. It's going to be kind of something probably like this. You've got A, B equals 32, and C. C is always going to be our hypotenuse. What makes it the hypotenuse is that it's across from your right angle. So A squared plus B squared equals C squared. So that's A squared plus 1,024, 4624. If I subtract 1,024 from both sides, I get A squared equals 3,600. A equals plus or minus the square root of 3,600, which is 60, or plus or minus 60. Now, the only reason I put in the plus or minus is because I want to remind you that when you're solving quadratic equations like this, that there is a plus or minus. You've got to remember that. But if you just gave me 60, how come you're okay in this case? How come there's no
Because it
minus?
can't be a negative 60 feet.
Yeah, you can't have a negative distance like that. So that's why you'd have the plus, just the plus solution there. So I've long since come to terms with the fact that I can forgive people for getting the plus or minus there. I don't worry about it. Distance between 2 points. Well, here's a couple easy points. If you're digging for points, if you want all you can, distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'll call that x1 y1 and x2 y2. That'd be the square root of 3 minus negative 9 squared plus 3 minus negative 2 squared, which is the square root of 12 squared plus 5 squared. 144 plus 25 is 169, and isn't that special? Works out to be a nice even 13. Midpoint. You know, the thing that amazes me about midpoint is that sometimes people just give me like a value, like a slope. Midpoint. Point kind of implies two coordinates. So it should be an x and a y coordinate. A lot of times I get just a single number. You know, people use the distance formula or the slope formula or something else like that. But in this example, you want to average the x coordinates, so negative 4 plus 7 over 2, negative 8 minus 4 over 2, which would be 3 over 2, negative 12 over 2. It's okay to leave it as an improper fraction, but this one I would appreciate if you simplify it as negative 6. Done. 2 plus 6i and 2 minus 6i. These are complex somethings. Anyone want to fill in the blank there?
Complex numbers.
That's right, but it's not what I'm looking for though. They are complex numbers, but they're also complex. We dealt with it earlier. Complex starts with a C. Conjugates.
Oh, 2 plus 6, 2 minus.
Conjugates. Yeah.
We know.
Conjugates. I don't know.
This is math, not even.
Yeah. I know, but you know what the funny thing is? My thesis advisor was so tough on my grammar. She's like, "You've got a dangling modifier there." And I'm like, "What is a dangling modifier?" I have no idea. All right. I actually did learn, but she was really, really tough. I defy anyone here to define a dangling modifier. But check it out with your English instructor. It is a real thing. Let's see. So, negative the square root of negative 8.
4.
I'm going to break that up into two parts. Yeah, a 4.
A negative 1 and a 2.
4, negative 1, and 2. So it gives me negative 2i square root of 2. Well done. The biggest problem here is that people want to foil that. No matter how big of a bold letter I put there, add or subtract, and how much I say at the beginning of class, people want to foil this. They want to go, oh, first that's it. No, just subtract. So it's going to be 9 minus 4i. And let's distribute that to both terms, minus 4 minus 7i. And then it's just a matter of like terms. You've got a complex part and a real part. So 9 minus 4 is 5. Negative 4i and negative 7i is negative 11i. Done. That's it. Make it easy on yourself. Are you noticing a trend here? Squaring a binomial. Third time here in this little review. 7 minus 2i times 7 plus, or 7 minus 2i again. Ooh, I almost put the conjugate. That would have been bad. There we go. Minus 2i. You've got to FOIL that out. 49 minus 14i minus 14i plus 4i squared. It's easy to forget that I squared term right here. So it's 49 minus 28i minus 4, right? Because I squared is negative 1 times 4 gives you negative 4. 45 minus 28i is your final answer. Okay. Kind of running low on time here. This is another one where you've got a radical in the denominator. It's kind of disguised because I is the square root of negative 1. So it is a little bit disguised, but it's still a radical in the denominator. We don't like those there. So you might remember one of our earlier problems when we had a radical in the denominator. What do we multiply by?
5 plus 3i.
Yeah, well done. 5 plus 3i, 5 plus 3i. And it's just a lot of FOIL work. Now, I'll let you check it and prove me right later. But in the denominator, you're going to end up with 34. In the numerator, you got to FOIL things out. So, tell you what, now on the test, you're going to have to FOIL things out yourself. But I don't mind you checking things. Now, this, unfortunately, is not something you can do with Desmos. Desmos is super awesome, but you can't do this with Desmos. So let me clear this out. Yes, clear, clear. But you can borrow a calculator. So let's take a look here. It'd be 6 plus 2i, 2i, times 5 plus 3i. Now, do yourself a favor. Don't rely on this kind of trick at home, other than checking your answers. Because what's going to happen? When you come in and take the test, and I ask you to show your work, you're not going to know how to do it. All right? You do need to practice this the right way. But in the numerator, you should have 24 plus 28i. That's what it should be. Now, sometimes WebAssign is going to ask that you break that up a little bit. They're going to want you to input the answer as 24 over 34 plus 28 over 34i. Now you can put those in lowest terms, yeah, whatever, you know, that's fine. You can reduce this to 12 over 17 and 14 over 17 times I. Fine, great. The big thing is that you start out by multiplying by the conjugate. If you just did that much, I might give you a point right there, because I'll be kind of happy to recognize the problem. These, there was only one power of I that I said you had to have memorized. Does anyone remember what it is? I squared. What does I squared equal?
Negative 1.
I squared, thank you. And thank you at home. I squared is negative 1. So with this, I can write that as I squared to the 12th power. 12 times 2 gives me 24. But then I realized, oh, well, wait a minute, I know what I squared is. That's negative 1. And negative 1 to an even power is going to be positive 1. Done. The only tricky part comes in when you have an odd number like this, I to the 93rd. So we're going to play the same game that we did earlier today when I had the square root of like a to the 5th power. I broke off one of those a's so that I had a to the 4th power. Now here I'm going to break off one of the i's so that I have I to an even power. Now notice there's a little difference. Here, when you have a power to a power, the exponents multiply. Here, when you've got a product of two things, they add, right? Product of two things with the same base, you add the exponents. Now, here's the trick. After this point, we're going to kind of ignore that I to the first power. We're just going to leave it by itself. We're not going to really touch it the rest of the way. I'm going to start out by writing this as I squared to some power. I still have that times I here, and I kind of keep that in green a little bit. What times 2 gives me 92? I'll help out here, 46. Okay. And then what? What can I simplify here? Yeah, I squared is -1. So I have -1 to the 46th power times I. -1 to an even power is +1. So it's just going to be 1 times I. And 1 times I is just I. And that is your final answer. And that is your review. If you can do the problems on the review, you should rock this exam. There's really not much more I could ask you outside of this review. So, any questions? One question here. Go ahead.
So, can I go over, maybe email you about the absolute value?
Yeah, just a quick reminder. Now, the absolute value is not really going to figure into this test much, but just a quick reminder, you know, when you have nth root of some number to the nth power, when these things match, then you'll get just A if n is odd. And you get the absolute value of A if n is even. So as kind of a quick example, if I had the 7th root of A to the 7th power, then it'd just be A. If I had the 8th root of y to the 8th power, then they get the absolute value of A. So that's kind of the quick summary of this. Now, you wouldn't need the absolute value if you were told in the instructions of the problem, assume the variable is positive. If the variable is positive, you wouldn't need the absolute value. Okay? So, good reminder question there. Thank you. Anything else? All right.
So, for
Yeah.
the last, the I on 25th power, can we just put I without going up to wait?
You can put I. Yeah, but I'm not sure how much credit you're going to get on your exam. I need to see the work. I absolutely need to see the work. I have no problem telling you that, hey, you can take out your calculator and double check it. I mean, there's nothing wrong with that. So I to the 96 power, oh, that's, oh, wait. Oh, we did 92 power, 93 power. Now, sometimes this doesn't work depending on the power. Sometimes you get something which I could make sense of for you, but you might not make sense of for yourself. But it does tell you got the right answer. So it's not enough just to give me the answer, all right? I mean, there's another way to do powers of I that involves knowing the pattern, dividing by 4, and looking at the remainder and figuring out which one in the pattern you're at. And that if you do it that way, that's fine. But again, just show me some work, all right? There's not, I don't think I'm asking too much in asking for that. Okay, good luck with your exam. We'll see you on Wednesday.